So for today's lesson, we're going to learn about tangent. We've talked about it a little bit in the past, specifically in terms of like SOHCAHTOA and triangle ratios. Now we're going to see how this ties into our unit circle. So before we take any notes or anything, check out here. We have our unit circle. We have our sine line, which is the height of our triangle. We have our cosine line, which is our width of our triangle. And now we have this new line, tangent. And what tangent does is it basically makes a right angle with our hypotenuse and runs all the way to the midline of our circle. So as that triangle kind of moves around, if we were to draw that triangle and have it get really close to the bottom of our circle, our tangent line would be really short because that right angle would just keep it down there. Conversely, if we were to draw a unit circle triangle that was up higher, that tangent line here would get really long because it's making a right angle with that hypotenuse. And in this case, it would go way past the screen here. So we're going to be dealing with some really big numbers and some really small numbers today as we deal with tangent. So that brings us to our notes. So right in the first section there's a spot for calculating tangent. We're going to write down two ways that we can do this. It can be calculated by either finding the opposite side of the triangle and dividing it by the adjacent side. That was our TOA in our SOHCAHTOA day. It can also be found by dividing sine by cosine. And let's look at that. If we were to apply SOHCAHTOA back to this triangle, right? Sine is our opposite side and cosine is our adjacent side. So it makes sense that in this case, using sine divided by cosine would work. So pause your screen, get these notes caught up, and then we'll move on. All right, now we're going to actually go through and calculate tangent for a bunch of different spots in our unit circle just to kind of explore how this operates. So everyone should have their unit circle out. We're going to pull cosine and sine values. We're going to plug them into our calculator to calculate for tangent. We're going to do the first three of our table together, and then you're going to fill out the rest. So if we start with 0 degrees, all right, we can go to 0 degrees. We can see that, all right, the sine value at 0 degrees is 0. So my tangent is going to be equal to 0 divided by my cosine value is 1. And if we do 0 divided by 1, tangent is 0 there. So we can leave it as that. If we want to jump to our 30-degree angle, which is next, all right, that is here on our unit circle. My sine value is 0.5. My cosine value is 0.87, so we're going to do 0.5 divided by 0.87. Let me get my calculator out. 0.5 divided by 0.87, that equals 0.57. We're going to round to 2 decimal spots there. So 0.57. And let's do one more before you finish the rest of this table here. I'll do this one in green. 45 degrees. If I draw my line at 45 degrees, I'm going to do sine divided by cosine. So I get 0.71 for my sine divided by 0.71 for my cosine. And if we have one number divided by the same number, we're just going to get 1 is our answer. So continue using your unit circle to finish completing that table. We should have all 360 degrees done. Go ahead and pause your screen until you are finished there. All right, so an activity that we did in class, and hopefully you have an opportunity to kind of look through while you're making this up, is start to think about what did you notice about tangent as we went? Were there any spots that gave you an error or undefined? Note where those spots were. Were there any repeat values that happened? What patterns did you notice? And kind of think about that real quick before we move on to our graph. So moving on to our graph, Similar to our sine and cosine graph, I've given you the image of our graph here on the left. I want you to jot down these key features here as we look at the right. So when we built up our table, we probably noticed that our graph started at 0. Our values started at 0 degrees, and they went up, 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 and then all of a sudden they hit this spot that was undefined. At 90 degrees, we were undefined. And that was because we were dividing by 0, which we cannot do. And we made the jump from way up high all the way down to the jump way down low here at the negative. And that's really the main thing I want us to take away from this graph here, is that it's not continuous. It's still going to repeat just like our sine and cosines graph do, but we don't have one smooth curve. Every time we hit every 180 degrees starting at this 90 degree spot, we're going to hit that undefined spot where we're dividing by 0, where cosine equals 0. And that is kind of the key characteristic of the tangent graph here. Moving forward, I know we're buzzing ahead and covering a lot in tangent today. We also can transform this base graph. So if we're given this base graph that you guys just kind of studied and got some key features down on, we can also transform it just like we did with sine and cosine. Right? Look at this formula structure, a tan bx plus d. It's just like we saw with a sine and a cosine. And these coefficients are going to mean the same thing. This a is going to be our amplitude, this b corresponds to the period, and d is going to be our vertical shift. So make sure you get this formula written down in your left box. We also have these definitions written down for you already in your notes. Keep in mind, this is on the back side of our sheet. So to close out our notes today, I just wanted to kind of explore this tangent graph with you and for you, so we can recognize, hey, what happens when A changes, B changes, and D changes, so we can pick these out. So if you go to Desmos and pull out the Desmos activity titled Tangent Graph, you will be able to play with an A slider, B slider, and D slider. That will allow you to kind of modify the shape of the tangent graph and, in your own words, describe what happens when the amplitude changes. How are you going to be able to tell when the amplitude changes? Then you can repeat that for when B changes. So we'll repeat that for the B slider using the Desmos to explore that. And finally, for the D slider, we'll be able to play around with that and come up with our own words there.